Rust's brand new borrow checker is coming, and all our compiler errors are about to disappear once and for all. Alright, in all seriousness, let's talk about Polonius, Rust's new borrow checker. How it will make your life easier when writing Rust, and when you can actually start using it for your Rust projects. So the borrow checker is Rust's compile time memory safety system. Before your code ever runs, it validates that references are always valid, that you don't use data after it's been freed, and that you never end up with conflicting mutable and immutable access, which can cause data races. To put it simply, the borrow checker is the reason Rust can guarantee memory safety without a garbage collector. Now, the problem with the current borrow checker is that it's fairly conservative, so there are cases where it rejects code that is memory safe in practice, but the borrow checker cannot prove that it's memory safe. And so you get GitHub issues like this, which call for improvements to the borrow checker, so that it ends up accepting more valid code. And that's the reason the Rust team has been working on Polonius, the codename for Rust's new and improved borrow checker. The goal of Polonius is to accept more valid Rust code, making the lives of Rust developers a lot easier. Now, here's a really good example of the shortcomings of the current borrow checker and how Polonius would help fix it. In this example, we call getMut on a HashMap, which returns an option type. If the value exists in the HashMap, we get back a mutable reference to it. If the value does not exist, we get back the none variant. Now the problem is calling getMut requires a mutable reference to the HashMap. That mutable reference has a lifetime of tickr, which lives until the end of the match expression. But in the none case, if the value doesn't already live inside of the HashMap, we want to insert a value into the HashMap. However, we cannot do that because inserting a value also requires a mutable reference to the HashMap. And the borrow checker doesn't allow two mutable references to the same piece of data at the same time. Now, if the borrow checker was smart, it would realize that the mutable reference on this line is only needed until the end of this sum branch. However, the current borrow checker extends this lifetime until the end of the match expression, which is why we can't get another mutable reference in the none branch. These are the type of issues that Polonius was built to fix. Polonius would understand that this mutable reference and this mutable reference do not overlap, and would successfully compile this code. In general, this new Polonius borrow checker would lead to more valid code being compiled, fewer workarounds for developers, and most importantly, no loss in memory safety. Rust's memory safety guarantees would remain exactly the same. So here's a GitHub PR for stabilizing Polonius, at least the alpha version, in Rust nightly, where all the experimental features live. And 3 weeks ago, we got this status update. And the most important section here is this third bullet point, which states that a lot of testing and perf runs have been done on thousands of crates on crates.io. And overall, the results were not bad at all. On the 20,000 most popular crates that were tested, the average compile time increase was just 1.4%, with 75% of cases seeing less than a 2% regression in compile times. There were a couple of outliers that had a 36% regression, and the worst documented cases had a 2.5x hit. But overall, again, the compile times remained pretty much the same, which is an important concern to address because Polonius does require more sophisticated compile time checking, which does risk increasing compile times. This update also mentions that there's been a lot of planning to prepare to stabilize Polonius in nightly Rust. So when will Polonius be released, and when can you start using it in your Rust codebases? Based on the recent update, my guess would be that we'll see Polonius in nightly Rust sometime in the next 3 to 6 months. At this point, the work that remains is fixing some last known soundness issues, validating performance, and rolling out Polonius safely. Of course, that's just my prediction, and the Rust team hasn't released an official stabilization date. One interesting thing about Rust is that most languages evolved by adding on safety over time. C++ now has smart pointers and optionals, so does Java. TypeScript was created to give JavaScript a stronger type system, and so on. But Rust did the opposite. It started off with a really strict type system and safety checks prioritizing memory safety, and then over time we're seeing it become less restrictive as we find new ways to make the compiler smarter while still maintaining maximal memory safety. Overall, I think this is a very interesting approach and makes a lot of sense for systems programming, but let me know what you guys think in the comment section down below. And if you're interested in learning how to write production-grade Rust code, check out our Rust Live Accelerator. It's our tailored mentorship program where we help developers go beyond YouTube videos, build production-grade Rust systems, and land their first Rust job. You can join the waitlist for our next cohort by heading over to letsgetrusty.com/join or by clicking the link in the pinned comment below. When you join the waitlist, we'll also send you our Rust developer roadmap as a small gift. So tap the link, join the waitlist, and I'll talk to you very soon.